Number 29. A beam of white light goes from air into water at an incident angle of 75 degrees. At what angles are the red and violet parts of the light refracted? All right, so here in black is our incident ray, and the angle of incidence, they tell us, remember, it's always with respect to the normal, all right, the perpendicular line of the surface, and that they tell us it is 75 degrees. So they just want us to calculate now these two angles of refraction here, and they are always again in relation to the normal. All right, so these two angles right in there. So here we're going to need table 25.2 it is. We need to know the indexes of refraction of the red light in water and the violet light in water. It turns out that white light is composed of a spectrum of colors. All right, and since each different color is associated with a different wavelength, they both will vary their speeds differently, basically in the water, and therefore they will have different angles of dispersion. All right, so if you notice, the violet index is greater than the red index, and therefore this violet should be refracted more, okay, or it bends closer towards the normal. So all we now need to do really is just kind of calculate using Snell's law. In other words, that the index of refraction for the incident ray multiplied by the sine of the incident ray should equal then the index of refraction for the refracted ray multiplied then by the sine of the angle of refraction. So you're going to look at this individually. All right, let's do for the purple first. It doesn't really matter. The index of the light in air is going to be 1. So basically, violet light, red light, they're going to be so close to 1 in air. Just use the value of 1. Okay, multiplied then by the sine of that incident angle of 75. That will then equal your index of refraction of the violet light in the water. So that's now 1.342 times then the sine of the angle of refraction. Simply divide this value on over, right? And then you realize that you're left with sine of theta, but you got to take then the inverse sine, right, to get rid of it. So you got to do that to both sides. So you're simply going to then take all this and plug it into the calculator as the inverse sine of all this mumbo jumbo. All right, so that means that our theta, our refracted angle here should be, let's see what we get. So inverse sine of sine of 75 divided by, divided then by 1.342. Okay, and here we're going to get a value of about 46. So picture's not the best thing to scale, but 46.0 or so degrees. All right, so now what we're going to do is we're going to now do the for red light. Now the only difference is the red light, you're going to cross out the value on the bottom, and you're going to plug in 1.331. Redo that calculation. Inverse sine of sine of 75 divided then by 1.331. Right, and now here we have a value of 46.5, and as you can see, the angle has now increased, okay, because there is less refraction. All right, so what are the angles? Yeah, there you go. Guys, thanks so much for tuning in. I appreciate it. Please help us out by subscribing and even hitting that like button. All right, we appreciate it, and we'll see you in the next one. Take care.